Yes, last time we have done two-dimensional vector, and now we are taking three-dimensional. This is our x-axis, this is our y-axis, this is our z-axis. This is horizontal. And this is some point P we have, which will be having coordinate x, y, z. And if you take the vector OP, then OP will be the position vector of point P. OP will be the position vector of P, that is OP vector. And as it has three coordinates, we should have OP vector as xi plus yj plus zk. This is your OP vector. This is the position vector of point P we can have. That will be in three component form. This is x component, this is y component, this is z component. X component, this is x is the length of this x coordinate. X coordinate is x and it is along x axis, so it is I cap. Y along the y axis, so y j cap and z k cap. I cap is the direction given for x axis. This will be for y axis and this will be for z axis. They are unit vectors along x, y, z. So OP vector which you are having will be xi plus yj plus zk. One more thing you should keep in mind whenever I say magnitude of OP vector, then it will be under root of x square plus y square plus z square, just like the two-dimensional geometry we have. And then we have the unit vector. Formula says OP vector by magnitude of OP. OP vector is simply xi plus yj plus zk by under root of x square plus y square plus z square. This is your unit vector in three-dimensional one. So this is same as the two-dimensional one we have done. Position vector will be, earlier it was xi plus yj, now it is xi plus yj plus zk. Modulus of the length of this vector is this given. Unit vector will be OP vector divided by magnitude of OP, so you got that also. For that, first we'll do few questions and then we'll come on scalar or dot product here. Right question please. Write the unit vector. Write the unit vector along the direction 3i minus 6j plus twice of k. This is some vector given A. My question is find out what is unit vector along this. So it's a three-dimensional vector we have. So we should find out what is the unit vector of it. So unit vector we should keep in mind, it is A cap is what? Vector divided by its magnitude. Vector will be clearly 3i minus 6j plus twice of k, and this will be under root a square, that will be 9, 36 and then 4. Will come out to be 7, root 49, so it will come out to be 7. So it will come out to be 3i minus 6j plus twice k is your a cap. That is the unit vector. So any vector given, its unit vector you can calculate. Another question is, there are two vectors A and B. Find the unit vector along A plus B. Where A vector is given as 2i minus j plus twice of k. Another vector is B vector, that is minus I plus j minus of k. My question is find out a unit vector along A plus B. So first thing what I should do, I should find out what is A plus B. 2i minus I, it will be I, this will be 0j and this will be k. Let this new vector is C. And we want a unit vector here. So I should say C cap to be calculated, C vector divided by magnitude C. So it will come out to be I plus 0j plus k by under root of 1 plus 1. So it will come out to be I plus k by root 2. This will be the unit vector along a plus k. Same way, one more thing we can ask, one more question, write down please. Find a vector of magnitude 11. Find a vector of magnitude 11. So there is a vector A we want, whose magnitude is given as 11. And it is in the direction opposite to PQ. And it is in the opposite direction to PQ. PQ की जो direction है उसके opposite है. Where P and Q are having coordinate as 1, 3, 2. This is the coordinate of P. And this is -1, 0, and 8. So we want a vector which will be having magnitude as 11. And it should be in the opposite direction of PQ. So first what I should do here, I should calculate what is PQ vector. PQ vector will be what? Position vector of Q minus position vector of P. Q का position vector क्या होगा? -I plus 0j plus 8k. Minus what second will be? I plus 3j plus twice of k. Now when you solve it, it will come out to be -2i minus of 3j. 8 minus 2 will be 6 of k. This is PQ vector. The vector A should be in the opposite direction to PQ. That means what is the direction of this vector is needed, because magnitude is already given. Magnitude of A is 11. I want A vector means I need A vector when you write. It will be vector into its unit vector. So in this case, magnitude A is 11, but only the direction to be known. So A cap, if you want to calculate, that will be unit vector along QP, right or no? So first I'll calculate what is QP vector. QP vector will come out to be 2i plus of 3j minus of 6k. And now I want a unit vector of it, because whatever unit vector of QP, this is a QP vector, and its unit vector will be giving direction of this vector. So we find out what is QP cap. What this formula says, the vector divided by its magnitude. So I should say 2i plus thrice of j minus 6k by under root. What this will come out to be? 4 plus 9 plus 36. This is QP cap, and this is only you have as A cap. Now as you got A cap, so I can write now A vector is magnitude of A into A cap. Now if I calculate this, A vector magnitude is already given as 11. A cap is this now, that will be 2i plus thrice of j minus 6k whole divided by 7 it is, because it will be root of 49 here. So root 49 will be 7, so this will be the A vector. So they can ask unit vector from you or any vector parallel to it, so you should know this question. Now coming on next, that is cross product or dot product of the vector. So write down first topic, scalar or dot product. First topic, we are taking scalar or dot product. Scalar or dot product. Now first thing, what is the meaning of scalar? Scalar means scalar product. What we are saying, why we are saying it is because the result comes out as a scalar quantity. We are having two vectors, we will take their product and the product gives us scalar quantity. So that will be called scalar product. Why it is also called as dot product? Because representation shows dot here. So scalar or dot product shows scalar means the product of two vector coming as a scalar quantity, and a dot means the representation is giving with the dot. But before starting this, one thing should be clear. Whenever I say angle between the two vectors, whenever I say the angle between the two vectors, if you have these two vector, or you have these two vectors, when I say angle between the two vectors, one thing should be clear. Angle between the two vectors is only going to calculate when they are co-initial vectors. Means if the vectors are like this, their initial point is same, then we will say the vector is having angle theta. In this case, you will say they are not co-initial. When they are not co-initial, you can't say that the angle between these two is this. No. In that case, what I should do here, I should extend this vector here. Make them co-initial. Same vector, whatever the magnitude of it, I'll take this, and direction is also same, then this angle will be called as angle between these two vectors. In this case, the problem is what? They are coterminous vector. Again, we will say angle between the two vector. If you want, then you should extend it. Means one of the vector I'll take here. Then now they will become co-initial and the angle will be taken. So whenever you have the angle between two vectors, the vector should be co-initial. That you should keep in mind. Now coming on dot product definition. Write down the definition please. A and B. Two vectors we are taking. Now we have to find out their scalar or dot product. So definition write down please. Let A vector and B vector, two non-zero vectors. These must be two non-zero vectors. Non-zero means their magnitude has not to be zero. Non-zero vectors. So two non-zero vectors we are taking, inclined at an angle theta. When I say angle between the two, keep in mind the angle if you are taking, they must be co-initial vectors. So this is vector A, this is vector B, angle between them is theta. Then after that write down, then the scalar product between the two vectors or the dot product between the two vectors will be denoted by A dot B. Scalar product between the two vector A and B or the dot product between A and B will be denoted by this and defined as magnitude A, magnitude B cos theta. A dot B, A and B, their dot is used, so that's why it is called dot product. Second thing, because here is no vector quantity left, it is called scalar product. Why it is called scalar? Because these two are vector, but the result is a scalar one. Scalar means without vector quantity. And why it is called dot product? Because representation shows dot in between. So A dot B will be magnitude A, magnitude B cos theta. This is called the scalar or dot product between the two vectors. Scalar or dot product. What I told you in this case, A and B should be two non-zero vectors. Their magnitude has to be A and B. So we will say A dot B will be defined as magnitude A, magnitude B cos theta. Theta is the angle between the two vectors we should have. So this is the definition of scalar product we have. After getting scalar product, one more thing now we should know, that is what is geometrical meaning of dot product. Geometrical meaning of dot product. Now in geometrical meaning, if you want, this is vector A, this is vector B, this is angle theta we have. And if you want dot product, one thing already we have done, that is A dot B is magnitude A, magnitude B cos theta. Now I do one thing. I'll just take a perpendicular from vector B. Whatever this terminal point, from where we draw the perpendicular on it. A point, this is point A I am taking, this is point B I am taking, let this is a point P. Then this OP part, whatever this OP part you have, This OP part is called as projection. This OP we call as projection or shadow of B vector along A. B का projection along A is OP vector. So OP is what? OP is a projection of B along A, or also called as component of B along A. Component of B along A. That you should keep in mind. So OP is what? Projection or shadow of B along A. B की shadow अगर आप देखेंगे A के along, तो ये आपका OP shadow देगा. Now, if we want to calculate OP, I take this triangle and I find out what is cos theta. Cos theta says base over hypotenuse. So base is what? OP. Hypotenuse is what? OB. OB means it is magnitude of B. Okay, we can't say B vector. It is not a vector quantity, it is a magnitude we are taking. So what I get here in this case, OP will be magnitude B cos theta. This is our OP. So here in this case, you got OP is coming B cos theta. So here this dot product, what I can write here, just check. This I can write magnitude A as it is, into this will be magnitude B cos theta. And in words, if I write, this is called magnitude of A vector. Magnitude of A vector. And what is B cos theta? This is projection of B along A. Projection of B along A. So what is dot product now? Dot product is actually the product of magnitude of first vector and the second vector's projection along first. एक तो ये पूरा वेक्टर A लेना है और फिर उसका कौन सा पार्ट लेना है? That is the projection of this along this first. So this will be the dot product. So geometrically what it shows, it is the product of magnitude of first vector into magnitude of projection of second vector along first vector. This is the result you have. And from this now you can have a formula. A dot B by magnitude of A will be this here. It is called projection of B along A dot B by magnitude A is projection of B along A. So that is the result you should remember. Whenever they say projection of B along A, that means A dot B by magnitude A. And what is the projection of B along A? This is B cos theta. So we should remember this formula. B cos theta is A dot B by magnitude of A. Second part now. If I draw a perpendicular from here, then this is point P. Then when you take this point as P, then OP is called projection of A along B. This OP, if you calculate now cos theta this time. Cos theta is what? Base. Base will be OP now, divided by hypotenuse is OA. OA means magnitude of A. So in the second part, what you will be having this time, you will be having OP will be equal to magnitude A cos theta. And magnitude A cos theta is this part. And what this is called, this is the shadow of A along B, or projection of A along B. So what I should say is, it is projection of A along B. Okay, so that means now what I should write this result, A dot B. Then in this case I'll write B here, and this will be magnitude A cos theta. Then what change will be here? Magnitude of A cos theta, if you want, that will come out to be A dot B by magnitude of B. Okay, and what is A cos theta? This is called projection of A along B. So if you want projection of B along A dot B by magnitude A, or if you want projection of A along B, then A dot B by magnitude A. This is the form B, sorry. This formula you should remember can be asked. And whenever A dot B, when you are taking what the A dot B is, magnitude of first vector. First vector is your choice, you are taking A or B. So it is A taken, then what it is, projection of second vector along first. अगर आप यहाँ magnitude of B लिखेंगे तो क्या चेंज आएगा? You can write this factor as this also. What I should write here, magnitude B, and then we will write magnitude A cos theta. This is what? Magnitude of B vector into. This is called projection of A along B. So anyway, you can write, this will be your formula, or we will say the dot product is one vector's magnitude into the projection of second in direction of first. That you should remember. This will be the geometrical mean. Now one more thing you should note here. When I say projection of A along B will be A cos theta. What the formula says, A dot B by mag B. You can write this result as A dot B vector by magnitude of B. B vector by magnitude of B means it has come out to be B cap. So this result can be written this way also. Here it is B cap, because vector divided by its magnitude, it is B cap. Same way if I say projection of B along A, then it will come out to be what? This is coming B cos theta. What is the formula here? It will be A dot B by magnitude of A, or you can write this as A by magnitude A into B. This is your A cap dot B. This is projection of B along A, we will be. So B along A is this, A along B will be this. Now coming on properties of dot product. Properties. So next topic we will be having properties of dot product, which will start next time.